So I have a little program that I'd like to walk through in the visualizer, and there's a bunch of different things going on in here that I want to go through piece by piece, so it's going to take a little bit to walk through a really simple program. But basically we're going to take this piece of code and we're going to print out values that are going to be 8, and we're going to see a bunch of different things happen. So I've got two variables, v and w, that I'm going to assign 5 and 3. And I'm going to add those two together. This is the addition operation for integers and floats. And I'm going to be using format. You notice here's a format. Here's where it's going to get substituted in. And I'm going to print out an informative message. The v plus w equals this value that I've created over here. So let's visualize it. And this is actually the kind of thing that I think in my brain goes on when I look at code, is what's actually happening inside the computer. And when I have something where I assign a variable a value, I have that mentally in my model of this is what's going on. So v takes on a value of 5, w takes on a value of 3. And then I come to this print statement, which I'm expecting to produce some output. And it prints out v plus w equals 8. Now notice that there's an operator plus there that adds those two together. This is a numeric addition, not a concatenation. So it's giving me the results of that calculation printed out. Now, one of those features that Python allows for is for you to assign multiple things in a single line. So you'll know I've got v comma w equals 4 comma 2. And that's, one way you can do an assignment. I could have put those two on 2 lines, but I'm going to do v times w. Now, the times operator in Python is a star. That's that little guy right there. But I'm going to spell it out as times so you know what it is. So if we step through that, we'll see that yes, 4 and 2 changed both of them inside the memory with that assignment, and now we'll do the multiply and get the output. And I get 8. Now down here I'm going to do division, and there's 2 different division operators. There's slash, which does an integer division, and slash, which does a floating point division. Now, I want to divide by 2, so w already has 2 in it, right there. So I just need to change v to something so I get 8. So, change v to 16, because 16 divided by 2 is 8. And then the first one prints out as I would expect, 8. And the second one prints out 8.0. That 0.0 indicates that this value has been converted to a floating point number when we did this operation. Because, when we divide things that are not even, like if I divided 17 by 2, I would have gotten 8 point something. So, let's do where we do subtraction. Now, v is 16, so if I subtract 8 from it, I'll get 8. And yes, that produces 8. Now, there's one more division operator that you're probably not used to seeing. And it's a little bit invisible in the formatter at the moment, or in the visualizer at the moment, but it's a percent sign, and it gives you the remainder. It's just there, right there, and there's a W that is there. If I scroll over, you'll see it. V percent W, which is the remainder from division. And let's run that one. And I've set up some values so that, yes, the remainder from dividing 17 by 9 is 8. So the remainder from the division. Now, this kind of a frame over here that's the global data that I'm thinking about, this is what I'm thinking about in my head. This is my mental map for what would happen with these variables. And there are more complicated mental maps, but you need this mental map. This is your model of the interior of the computer and how it works. So when you assign a variable, I'm thinking about, yes, this value that I calculated, or this result that I got, it went over and it went in a location in memory, and I'm keeping track of it by name. Now, I should say something about names. I just use single letters here. It's perfectly legitimate if you're only going to be a few lines of code to use a single letter. If you have something that is more complicated than a few lines of code, like maybe 15 or 20 lines of code, you need to give the variable a realistic name so that you can actually understand it. Now, I'm going to go back and actually put in some automated test cases for this so that you can see what an automated test looks like. Because in our actual code for the class, you're going to be expected to do tests. So right here, we'll put in an automated test. Now I've changed the code slightly so that we have a result, r is equal to v plus w. That's going to make it easier to do our test. But basically, this line just takes that r plus w and prints it out. But down underneath, I've done something else. I've added this conditional piece of code that says if r is not equal to 8, now the value I'm expecting as a result is the 8, and that exclamation equals is not equal. So any value other than 8, and I print out this failed. V plus W incorrect result, expected 8 got whatever R is that isn't 8. Now this is kind of a really rudimentary example of building a test, but I know that if I start seeing things that say failed, that then I've failed to pass the test and this piece of code isn't working. And we're going to work more on automated tests as we go on, but I wanted to put in an example of one. So let's visualize the execution. And what I'm expecting to see is just results as I walk through, like I'm going to assign things, it's going to calculate. I can see now that R is 8. So when we say if R is not equal to 8, well, R is going to be equal to 8. It's going to skip that. So let's print it out. We got 8. And what happens at the if? It skips over that piece of code and goes on to the next one. And we don't see failed because it calculated the right value. Now with just adding 2 values, that test isn't very useful. But when we build more complicated things, being able to say, yes, I have put in some input values and I've gotten some expected output values suddenly becomes really important. All right, some takeaways from this. First of all, we've got plus, okay, star, 2 different kinds of divides, subtract, and modulo remainder. Those are operators that we can use on numbers. And we can use them on both floats and integer values, but we get different results, as in this gave us a floating point result and we may not want a floating point result. Second thing, you can do multiple assignments with this comma operator. Basically, it took the stuff on this side, on the right, and put it into the stuff on the left. We used format multiple times to format values. That's examples throughout. And the last one is when we wanted to do a test, I really wanted the value from v plus w to be in a variable so I could compare it and not calculate it again. So I put it in a variable and I compared against the expected value with a not equals to say, if it didn't give me the expected thing, then I know I have a problem. And I printed out a result that was, this was an incorrect result. Note in the printout, I put both what I expected and what I got, so that if I have to go back and test it, if I have to look at the output and say, well, did that test do what it was supposed to? Okay, I can look at the results and I can say, oh, okay, I understand this is what's going on in the test. So I was clear about my output and what it was that I was doing.